Hi everyone. So we are doing a new chapter of Standard 8th Science. A very interesting chapter because these type of things we see it always in our day-to-day life. What is the chapter called? Chemical change and chemical bond. Okay, so let's start. Now can you see on your screen so many things, whatever we can see on our screen, it's all around us. For example, breaking of a glass, freezing of a popsicle like an ice cream or something, spoiling of milk, cutting of grass, slicing bread, marshmallows, if you'll have seen how it is made, breaking of eggs, exploding fireworks, toast, water evaporating, squeezing of an orange, mixing Kool-Aid packets with water, like for example, mixing some Glucon-D or some Tang or some powdered ready-made drink with water, burning of food, popping popcorn, coloring your hair, melting chocolate. Okay, all these things we see in our day-to-day life. These types of changes are numerous in our lives, right? This is just some of them. There are many other things which we have been seeing all the way, all along, happening all around us. These changes are classified into two types. Now, very important thing to understand: physical change and chemical change. Okay, physical change and chemical change. Now we'll see what is the meaning of this physical and chemical change and how we can distinguish between these two things. Now can you see these four things? Now when you see, when ice, it melts, it is called as a physical change. Why it is called as a physical change? आइस का लुक और वाटर का लुक जो है टोटली अलग है, करेक्ट? Ice, it looks different. Water looks different. We look at a particular liquid, and if it is water, we cannot say it is ice unless it solidifies. Okay, so this is called as a physical change. Similarly, chemical change, you can see mangoes, when they ripen, it becomes a different color. And different color ही नहीं, टेस्ट वगैरह भी सब डिफरेंट होता है. जो रॉ मैंगो है उसका टेस्ट अलग है, राइप मैंगो उसका टेस्ट अलग है. That's why we call it a chemical change. Now we'll see some important points. You can even write it down if you want. Composition of matter remains the same in a physical change. Composition of matter मतलब अभी आइस में जो है वो पानी है, पानी का आइस बनता है, तो वो मेल्ट होने के बाद कोल्ड ड्रिंक या कुछ बनता नहीं है, वो पानी ही रहता है. सो कॉम्पोजिशन ऑफ मैटर मीन जिससे वो बना है वो सेम ही रहता है. देन chemical change, here the composition of matter changes. क्योंकि if you see the example of a mango only, टेस्ट टोटल अलग है ना. आइस का टेस्ट पानी जैसा ही है, ठंडा है पर पानी जैसा ही है. पर जब केमिकल चेंज एक it happens in a mango, here it is totally different, right? Because the taste changes, the look also changes. This change is a temporary change. Why temporary? क्योंकि वो आइस जो पानी होता है, that water can again be made ice, right? This is a temporary change, but this change is a permanent change. We cannot change a ripe mango to a raw mango. वो नहीं हो सकता है. This change only happens in physical. This change, there is a change only in physical properties due to change in the parameters such as temperature and pressure. So what happens here in physical changes? Physical properties are changing. मतलब the look of it is changing. And why? Because the temperature changes, and suppose there is pressure too much in that particular glass, or we press the ice with our hands. Okay, so heat exchange happens. So temperature pressure change होने की वजह से this physical change happens. But in chemical change, what happens? There is change both in physical and chemical properties. Raw mango, if you touch, it is not as soft as a ripe mango is, right? So physical change भी, physically भी ये change हो रहा है properties, और chemical properties भी इसका change हो रहा है. Why? Because there are chemical reactions which are taking place. Okay, this is often a reversible change, क्योंकि ice to water, water to ice वापस हो सकता है, but this is an irreversible change, like melting of ice and ripening of mango. Let's go ahead. Okay, some examples. Ripening of mango, this is chemical change. And if you see here, ice is melting, this is what? Physical change. And you can see here water boiling, this is what? Again, physical change. Q physical. क्योंकि वाटर बॉयल होके इवेपोरेट हो जाते हैं, तुम लोग बॉयल करते रहोगे, क्या होगा, सडनली देखोगे वैसे में पानी ही नहीं, पानी गायब, क्यों, क्योंकि सब इवेपोरेट हो गया ना, सब निकल गया. So physically it is totally changed. Next, some mixture is happening here. Dissolution of salt in water. Salt पानी में mix होता है, तो क्या होता है, physical change. Salt दिखाई देता है क्या, total mix हो जाता है ना, it is physical change. Bananas ripening, this is a chemical change. Fragrance of a ripening fruit is a chemical change. Ripening fruit, ripe मतलब ripe fruit का fragrance अलग है, raw fruit का fragrance अलग है. Darkening of a cut potato. We all know that a potato, once it is peeled, it darkens. This is also chemical change. Bursting of an inflated balloon. That is a physical change. एक बार burst किया तो balloon थोड़ी रहता है. Physically changes. Then sound of bursting crackers. This is obviously a chemical change. Chemical reaction is taking place. Rapid chemical reaction. That's the reason there is sound in the cracker. Foul smell from a spoiled food. किसी गंदे some खाना which is spoiled, कुछ खाना बहुत ज्यादा खराब हो गया है, उससे स्मेल आएगा, तो उससे एक फाउल स्मेल आता है. फाउल स्मेल मतलब कुछ डर्टी स्मेल और समथिंग. दिस ऑल्सो ऑब्वियसली इट इज केमिकल चेंज. So during any chemical change, composition of the original substance changes to form new substance with a different composition and properties. So chemical change में क्या होता है, composition of the original substance changes. Means what? Whatever ingredients that particular thing is made of, that composition is changing. Now for example, bread को तुम लोग फ्रिज में रखोगे या बाहर रखोगे for a long time. Okay, a long time I'm talking about, there are chances of it getting spoiled. So what happens is composition मतलब what that particular bread is made of, उसका भी properties change हो गया. So जब taste करते हैं spoiled taste आता है, right? Because there is a chemical change that is happening in that particular bread piece. Then what is this? An apple. Okay, apple also we know that jab, if you keep it for a long time, even if you keep it in a vessel or something, it changes color. So chemical change make color changes, taste changes, chemical composition. I just give an example of bread. Chemical composition changes, shape, size and texture changes. So if you see these nails अगर rust हो जाएगा तो उसका shape, size, texture भी change. Texture मतलब उसका जो touch करते हैं hardness वगैरह आ जाता है. Formation of a new substance. Totally new substance is formed and gas also evolution. Gas is given out. Absorption or evolution of heat. Heat is either absorbed मतलब heat आ जाता है substance में or it is given out. So we'll see some word equations of chemical change. Word equation मतलब an equation which is written in word. Okay, ये equation chemical equation है, not that equation which we do in maths. Chemical change is also termed as a chemical reaction. During a chemical change, chemical reaction, the chemical composition of the original matter changes. We had just said and we just discussed about it. And new substances having different properties and different chemical compositions are formed. The word equation and a chemical equation can be written for a chemical change if the exact change in chemical composition is known. तो क्या react होता है और क्या मिल जाता है as a product, if we know, we can write this in the form of an equation. How do we write in the form of an equation? Only names of the original substance and newly formed substance are used. So when writing a word equation, only the names are used. Okay, we don't write the chemical formula of it. Names and chemical formula of the original substance and newly formed substance are used while writing a chemical equation. So word equation only name is used, chemical equation में name भी use होता है and chemical formula of that substance भी use होता है. And if you see, there is an example of when baking soda is added to lemon juice, a chemical change takes place in and citric acid which is present in the lemon juice and gas is formed in carbon dioxide. Okay, so citric acid plus sodium bicarbonate gives us carbon dioxide and sodium citrate. Okay, so this is a word equation. Citric acid को sodium bicarbonate से react करेंगे तो क्या मिलता है, कार्बन डाइऑक्साइड मिलते हैं और सोडियम citrate मिलता है प्लस थोड़ा water. Okay, it's watery. This is a word equation. Now citric acid is an acid, sodium bicarbonate is a alkali or a base, carbon dioxide is a gas, Sodium citrate is a salt plus what? Salt matlab wo namak nahi. Okay, it is taken as a salty thing. Okay, there's not that salt which we use in our food. That is sodium chloride. This reaction is called as a neutralization reaction. Okay. Now, how we writing a chemical equation? Left side mein rehte the reactants and on the right side is the products. Okay, so original substance on the left, newly formed substance on the right. So arrowhead points towards the substances formed. So this arrow which is there on the right, it is why? Because on the right is the final substance which is formed, and arrow indicates the direction of the reaction also. So substances on the left hand side are called reactants and substances on the right hand side are called products. Place for the products of a reaction is on the right hand side of the arrow. So original substance is reactant and the newly formed substances are called as products. So 2 to 3 substances hoga, so obviously there is a plus 10 which is used to separate them. After writing a chemical equation, the equation has to be balanced. Very important. Left or right side mein total balance hona chahiye. Then only it will be in level. Balancing of a chemical equation means making the number of atoms of each and every element on the reactant side equal to the number of elements on the product side. So left hand side mein jo elements hai aur right hand side mein dono balance hona chahiye. So for example, when air is continuously blown through freshly prepared lime water, so this is carbon dioxide and calcium hydroxide. Okay, lime water is nothing but calcium hydroxide. The lime water turns milky. Air is continuously blown, matlab outside air, let us take an example that it contains mostly carbon dioxide. So carbon dioxide plus calcium hydroxide, which are the reactants, gives us calcium carbonate plus water, which are the products. Now a chemical equation of this, if we write, carbon dioxide ko likhte hain as CO2, calcium hydroxide we write as CaOH twice, gives us calcium carbonate we write as CaCO3 and water we write as H2O. So the top one is your word equation. अगर ये same word equation हम लोग को chemical equation में लिखना है, then we have to write the chemical formulae of all these this gas, this product and this reactants and products दोनों का chemical formulae भी लिखना है. For example, carbon dioxide का कैसा लिखा है? CO2, calcium hydroxide CaOH twice, calcium carbonate CaCO3 and water is H2O. Let's go to the next part. Chemical equations which are used in our everyday life, or you can say chemical changes. Chemical equation, why I said, so that we learn these changes in the form of chemical equation also. So these chemical changes which we see in our everyday life is nothing but changes in our surrounding, our body, home and in our laboratory. Okay, let's see some of these chemical changes for which we can even write a word and a chemical equation. Some natural chemical changes is nothing but this respiration, our breathing. It is continuously occurring in a biological process. Inhale, exhale, lungs are functioning. ये सब chemical change ही है. In this process, we inhale the air and exhale carbon dioxide and water vapor. After in-depth study, it is learned that glucose in the cells reacts with the oxygen in the inhaled air to form carbon dioxide and water. So, what we take in is oxygen and that reacts with the glucose inside our cells, and then what we give out becomes carbon dioxide and water. So, we write this in the form of a word equation. We can write it as glucose plus oxygen. Respiration process gives us carbon dioxide and water, and we write this as a chemical equation. Glucose C6H12O6, oxygen is O2. Respiration gives us carbon dioxide and water. These equations are very important. Please take it down or take a screenshot of it. Photosynthesis, इस process में क्या होता है? Sunlight and the plants, क्या होता है plants में? Sunlight is very important for any plant to grow and for trees and grass and everything on the grasslands to grow. But what happens is, what these plants and these trees and all give out, they give out oxygen. Okay, they take in carbon dioxide and they give out oxygen, which we use. And this water also is important. We have to water the plants and all, right? This is the process of photosynthesis. Glucose, which is there, which is produced inside the leaves of the plants, and oxygen is given out. Okay, we write this in the form of word equation. We get carbon dioxide plus water in the presence of sunlight and the green color of the plant. Okay, or the green plant gives out glucose plus oxygen, and if we write this in the form of a chemical equation, you can write as carbon dioxide plus water in the presence of sunlight gives C6H12O6 plus O2. Now some man-made chemical changes, for example पहला है ये combustion of fuels, ये man-made है ना, ये automatic नहीं हो रहा है. Okay, this is burning of some fuels, wood burning for example, coal ka burning, then petrol, cooking gas, this is all man-made. So this common substance that burns in all these is carbon. Carbon is the most common thing, or most important thing, because of which all these things are burning. During the combustion process, carbon combines with oxygen in the air and the product carbon dioxide is formed. A common equation can be written for all these combustion processes. So we can write an easy equation, carbon plus oxygen gives carbon dioxide. This is very simple to understand. Shabat tile is nothing but your shining vitrified tiles. Why they are claimed with dilute, concentrated करेंगे तो खराब हो जाएगा टाइल, इसलिए dilute hydrochloric acid जो फिनाइल वगैरह रहता है. The chemical composition of Shabat tile is mainly calcium carbonate. During its cleaning, HCl, the upper layer of the tile, reacts with hydrochloric acid and three products are formed. What are the three products formed? One is calcium chloride, which is soluble in water and it gets washed away with water. Second is carbon dioxide, it bubbles mixed with the air. And the third product is water, which again obviously mixes with water. So if we write this in the form of a word equation, we can write as calcium carbonate plus HCl gives calcium chloride plus carbon dioxide plus water. Chemical equation में calcium carbonate का chemical formula है CaCO3, hydrochloric acid का HCl, calcium chloride is CaCl2, carbon dioxide is CO2 plus water. Some man-made chemical changes also, let's see. ए और बी तो हमने देख किया, थोड़ा और देख लेते हैं. सॉफ्टनिंग ऑफ हार्ड वाटर. अभी ये हार्ड वाटर जो है इसको सॉफ्टनिंग करने का एक प्रोसेस रहता है. ओके, सो सम वेल्स और ट्यूब वेल्स हैव हार्ड वाटर इन देम. हार्ड वाटर क्या होता है? इट इज ब्रैकिश टू टेस्ट. ब्रैकिश मतलब थोड़ा व्हेन यू टच इट, इट इज यू फील दैट देयर इज सम केमिकल टाइप समथिंग इन इट. इट डज नॉट फॉर्म लादर विथ सोप. साबुन के साथ उसका वो बबल्स वगैरह, लादर बोलते हैं उसको, वो नहीं आता है. Then it is because hard water contains some chloride and sulfate salts of calcium. Okay, like some chemicals, calcium, magnesium वगैरह dissolved state में है, मतलब पहले से ही है उसमें. तो उसको soften करने के लिए क्या करते हैं? washing soda डालते हैं उसमें. So it becomes soft water. Soft water is what we get in our houses and all. Okay, this results in a chemical reaction to form a precipitate of insoluble carbonate salts of calcium and magnesium. As the dissolved salts of calcium magnesium go out in the form of precipitate of the carbonate salts, the water is softened. Okay, so ये reaction होता है. क्या होता है? Calcium magnesium जो है, they go out in the form of precipitate of the carbonate salt. Precipitate मतलब it is like a thick liquid. Okay, bubbly thick liquid, which is happening because of the reaction which is between calcium and magnesium. And carbonate salts are formed. कार्बोनेट सॉल्ट फॉर्म होगा पानी में, तो पानी होगा सॉफ्ट, which can be used then easily. Now word equation of this: calcium chloride plus sodium carbonate gives calcium carbonate plus sodium chloride. calcium chloride का CaCl2 है, sodium carbonate का Na2CO3, calcium carbonate CaCO3, CaCO3 and sodium chloride is NaCl. फिर पहली बात तो calcium chloride रिएक्ट होगा, फिर मैग्नीशियम क्लोराइड भी रिएक्ट होगा सोडियम कार्बोनेट के साथ, मैग्नीशियम कार्बोनेट मिलेगा और इसका वर्ड इक्वेशन ये है. इफ यू सी, दोनों वर्ड इक्वेशन बहुत सिंपल है क्योंकि यहाँ पे CaCl2 है, MgCl2 है. मैग्नीशियम का Mg है, कैल्शियम का C है, Cl2 सेम है, ये दोनों तो सेम है. कैल्शियम कार्बोनेट Ca इधर है इसलिए यहाँ पे Ca आया, Mg इधर है इसलिए यहाँ पे Mg आया, ये दोनों तो सेम ही है. Now what is chemical bonding? Okay, for chemical bonding we will see a very interesting video. Okay, so chemical bonding nothing but valency को compare होता है. ये valency क्या है, ये chemical bonding क्या है? chemical bonding ionic bond भी है, covalent bond भी है. ये ionic bond क्या है, covalent bond क्या है? We'll see this video and we'll understand it much better.
Electrons are arranged in energy levels or shells around the nucleus of an atom. The actual orbit shapes are a bit too complicated to cover in such a short lesson, but on average, the orbital radius increases as the energy levels increase. In our diagrams, the shell nearest the nucleus is going to represent the lowest energy level or shell, and we draw a circle to depict each shell. We use a dot or a cross to represent each electron, and we'll represent the nucleus by the chemical symbol. Each electron in an atom is in a particular shell, and the electrons must occupy the lowest available shell nearest the nucleus. So, when we are drawing the electron configuration, we have to fill up each shell in turn, starting with the lowest. We'll take a lithium atom as an example. With an atomic number of 3, it must have 3 electrons to balance the positive charge of the 3 protons in the nucleus. It's worth remembering that the atomic number tells you the total number of electrons in a neutral atom. So, we put the first electron into the first shell, and the second. However, this shell can only contain a maximum of 2 electrons. That's one of the rules that you need to remember. The third electron, therefore, must go into the next shell, which we draw as a larger circle around the outside of the first. And that completes the electronic configuration of a lithium atom. The same process of filling up shells applies to larger atoms. You always start with the lowest available shell, and whenever a shell is full, the next electron to be added goes into the next shell. And that's pretty much it. All you need to know is how many electrons can occupy each shell, and at this level, you only need to know the rules for the first 20 elements. The maximum numbers are as follows. The first shell can contain a maximum of 2 electrons. The second shell, up to 8 electrons. The third shell also has a maximum of 8 electrons. And the 19th and 20th electrons go into the fourth shell. And this would actually represent a calcium atom. Note that as we fill up each level, we've been drawing the electrons evenly spaced out on each shell. This is to keep the diagrams tidy and make it easier to count the electrons. And what's more, there's a shorthand way of writing this down. 2, 8, 8, 2. The first number represents the inner shell or lowest energy level. The full stop shows how the electrons are separated between the shells. The second number tells us how many electrons are in the next shell, followed by the third and fourth shells. And so now it's your turn. I'd like you to draw the electron configuration of a carbon atom. Pause the video, find a piece of paper and have a go. And here is what it should look like. It has a full first shell and 4 electrons in the outer shell. Did you get it right? Now, how would you write the electron configuration in numbers for this atom? Pause the video again or rewind if you need to have a think about this. The answer is that it would be written 2.4.
In the previous video, we got introduced to the versatile nature of carbon. Can you tell me why it is capable of forming so many bonds with so many elements around? To know this, let's have a look at the atomic structure of carbon first. Does the atom look somewhat like this? Yes. The electronic configuration of carbon is 2,4. That means it can either donate or accept 4 electrons to achieve stable state. However, it's not as easy as it seems. This is because donating the 4 electrons will mean that the atom is now left with only 2 electrons. But the number of protons still remain the same, right? That means the atom will gain positive charge and will still be unstable. Similarly, accepting 4 electrons will also lead to a situation where the carbon atom becomes negatively charged. Thus, both the situations would lead to instability of the carbon atom. So the option that carbon adopts is to share electrons. Sharing in carbon can take place up to 4 electrons. That means carbon can share all its valence electrons with any other atom. We know that such sharing of electrons leads to a special type of bond formation called the covalent bond. So to understand carbon chemistry, we need to understand covalent bonds first. How can we define a covalent bond, by the way? In simple words, it's the bond formed between atoms by the sharing of electrons. Now the next question that pops up in our mind is how many electrons need to be shared to form a covalent bond? Is it one electron or a pair? Or more than a pair? Can you guess? Let me help you with the answer. When we say sharing, it means that both the atoms need to contribute for the bond formation, right? It indicates that each atom will give at least one electron from its valence shell. Does that tell us that a covalent bond will involve minimum of one pair of electrons? Yes, a covalent bond needs at least 2 electrons or simply one pair of electrons. Such a type of covalent bond where one pair of electrons is shared between the atoms is called a single covalent bond. It is denoted by drawing a single line between the two atoms. A simple example that explains this type is the formation of a chlorine molecule. How do you think this molecule was formed? We know that chlorine has 7 electrons in its outermost shell. That means only 1 electron is needed by it to complete the octet. Now here's another chlorine atom which again has 7 electrons in its outermost shell. Both of them want 1 electron each. And that is why we find 2 chlorine atoms coming together and forming a bond by sharing 1 electron pair. Now if we look at this orbit individually, it has 8 electrons. And this orbit too has 8 electrons. Stability achieved for the chlorine molecules. This was an example of a single covalent bond. So do all atoms form covalent bonds by sharing a single pair of electrons? Think for a moment. We know that oxygen is in the diatomic state. That means one oxygen atom forms a bond with other oxygen atom to form a stable molecule. Do you know how many electrons are shared in this bond? What do you notice? There are 4 electrons shared. That means both the oxygen atoms contribute 2 electrons each, thus giving 2 pairs of electrons in the bond formation. So is this not an example of covalent bond? Well, it is. But covalent bond has 1 pair of electrons being shared, right? Don't forget, it is a minimum of 1 pair that's needed for formation of the covalent bond. That means this case is also an example of a covalent bond. Such a covalent bond which involves 2 pairs of electrons getting shared is called a double covalent bond. It is represented by 2 lines written between the 2 atoms. Just like this as seen in case of oxygen. Now on the similar lines, can you give me an example where more than 2 pairs of electrons are shared between the atoms? Wait a second. Are we trying to say that a triple covalent bond also exists between the atoms? Absolutely. And the best example to study this is the case of nitrogen. We always find a nitrogen molecule written like this. Needless to say that the 2 nitrogen atoms share a triple covalent bond. That means 3 pairs of electrons or simply 6 electrons are shared between the atoms. This helps both the atoms attain the stable state. Now tell me one thing. Which type of covalent interaction does carbon prefer? Does it opt for a single or a double or a triple covalent bond? Astonishingly, carbon has the ability to form all these types of covalent bonds with different elements. Yes, it can have any of these covalent interactions with atoms of other elements or even with other carbon atoms for that matter. In the next video, let's have a look at how exactly carbon forms bonds.
Ions, as you already know, are formed from the loss or gain of electrons. Electrons, however, do not suddenly appear or disappear. They are, in fact, transferred from one atom to another. Let's look at sodium chloride as an example. Sodium loses one electron to form a sodium ion. The electron is not lost, but transferred to chlorine to form a chloride ion. So we have a sodium ion and a chloride ion. They are oppositely charged ions and will be electrostatically attracted to one another, much like how opposite poles of a magnet are attracted to one another. This electrostatic attraction is an ionic bond. Sodium chloride is an ionic compound because it is held intact by ionic bonds. The same thing happens with magnesium and oxygen. Why don't you grab a piece of paper and a pencil and draw the resulting ionic compound, magnesium oxide? Please pause the lesson and resume when you are done. Magnesium transfers its two valence electrons to oxygen, forming a magnesium ion and an oxide ion. The resulting ions are electrostatically attracted to one another, forming an ionic bond. Did you get this right? Did you remember to include the charges on the ion? Now, let's look at calcium and chlorine. Calcium loses two electrons to form a calcium ion. One of these electrons is transferred to a chlorine atom, and another is transferred to another chlorine atom, forming two chloride ions. The calcium ion is electrostatically attracted to the two chloride ions because the opposite charges must fully balance each other out. In all three examples, the resulting ionic compounds have an overall neutral charge because all charges are fully balanced out. In summary, an ionic bond is defined as the electrostatic attraction between oppositely charged ions. When an ionic compound is formed, the charges must be balanced so that the resulting ionic compound has an overall neutral charge.